Now, these definitions for the mean and standard deviation, of course, are limited to a set of finite data. Right? We have, say, we take 10 measurements of a sample and get 10 different concentrations. We take the average, and we can also find the standard deviation. That's mostly how we'll use these values. In theory, though, if you can have infinite data, if we could, say, take hundreds of thousands of measurements over years, we can build up a large data set, using the same exact technique on the same sample. Realistically, this is generally not possible, but occasionally, if you have, say, an automated thing that's happening over years, you can approach what are known as the population mean, which we write as mu, and the population standard deviation, which we write as sigma. So we use the Greek letters for M and S, mean and standard deviation. So we can never measure these, of course, but the more data we get, so as we get more and more data points, our value of x bar will approach mu, and our value of S will approach sigma. And so that's one way of thinking of these, is like, this is the limit as we go to infinite data, right? If we could acquire infinity data points, we could get the exact distribution. But any measurement we actually take will be limited. And so we'll only be able to get an approximation of the mean and standard deviation.